Perkenalkan, nama saya Darlin S. Di sini saya akan mengajak teman-teman sekalian untuk menyaksikan cuplikan mengenai apa itu destilasi, rangkaian destilasi, dan untuk apa kita mengetahui mengapa pentingnya itu destilasi. Berikut cuplikannya.
Professor Dave here. Let's do some distilling.
He knows a lot about the science stuff. Professor Dave explains.
We've learned a few different techniques for separating the components of a mixture. Extraction utilizes differences in solubility. Chromatography utilizes differences in polarity. There is another technique that utilizes differences in boiling points, and it's called distillation. Let's go ahead and check out a distillation apparatus now, along with some instructions and tips for how to do this properly. The idea behind distillation is quite simple to understand. Given a mixture of two miscible liquids, if they have very disparate boiling points, we should be able to heat up the mixture to a temperature that is above the boiling point of one compound, but below the boiling point of the other. This will cause the one with the lower boiling point to go into the gas phase, such that we can collect the vapor and condense it elsewhere, while the one with the higher boiling point will just stay right where it is. And in fact, the technique is pretty much as simple as that, but there are a lot of things to discuss regarding the setup, so let's see what this looks like. Here we can see a distilling flask, usually a round-bottomed flask, and our mixture will go in here, along with a couple of boiling chips. This will sit above the heat source, be it a hot plate, Bunsen burner, or whatever we are using. We bring the mixture to a gentle boil, and vapor is produced. This vapor will rise into the side arm, and a thermometer will sit here, measuring the temperature of vapor right as it approaches this horizontal section. The vapor continues into the condenser. This has a central hollow section where the vapor will pass, surrounded by another section where cold water will enter on one side and then exit from the other. This will be constantly running and against the direction of the vapor. This cold water will cause the temperature inside the condenser to drop, so when the vapor enters this section, it will condense back into a liquid. This liquid is called the distillate, and we will collect it in a receiving flask. And just like that, separation is achieved. Now let's mention a few quick tips to make sure your distillation goes smoothly. First, make sure your distillation flask is not more than half full. If it is too full, some of the unwanted substance might make it into the distillate. Second, make sure your thermometer is in the right position up here, as we want to measure the temperature of the vapor, not the liquid. Third, make sure your heat source is easy to remove very quickly. If it's a Bunsen burner, make sure the setup is such that you can just pull the burner away instantly. If a hot plate, make sure it's easy to loosen one clamp and pull things apart easily. It's possible for the mixture to suddenly begin boiling violently, and we need to remove the heat right away if that happens. Fourth, make sure every piece of glassware is clamped properly, especially the condenser. Clips should connect everything. And lastly, it's sometimes a good idea to just collect distillate at the desired temperature range that corresponds with the boiling point of what you want. This will minimize contamination. So we can see how this technique is useful for separations. It can even be used in the context of a reaction. Say you're doing something like this, the dehydration of cyclohexanol by phosphoric acid to produce cyclohexene. The starting material has a boiling point of around 162 because of its size and hydroxyl group, while the product boils at around 83. Since we want to heat this reaction up for it to proceed anyway, we can just perform the reaction in a distillation flask, and the distillate will be our product. Reaction and isolation of product all at once. There are other ways to do distillation too, like fractional distillation. This utilizes a fractionating column to separate mixtures with many components, like the atmosphere, or certain mixtures with industrial applications. Things also get tricky if the mixture being distilled is an azeotrope. This is a mixture of two or more liquids that, when boiled, the vapor will contain those constituents in the same proportion as the liquid, and it will boil at a temperature lower than any of their individual boiling points. Ethanol and water is an example of such an azeotrope, and we will need special techniques for such mixtures. But we will have to look at these techniques another day. For now, that wraps up our introduction to basic separation techniques for the Organic Chemistry Laboratory. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.
Itulah tadi teman-teman mengenai cuplikan mengenai destilasi. Semoga cuplikan tadi bermanfaat ya buat teman-teman. Baik, dari saya sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.